All right. How's about? Are you talking about like one from yesterday's homework? Is this yesterday's homework? Like the first problem? There aren't any ones that don't have consecutive numbers. What are you talking about? Oh, on today's home. Oh, I see. Okay. All right. All right. I'll tell you what. I'll do one from yesterday, and I'll do one from today. Um, quick, throw it out there. What do you guys want from yesterday? Which one do you want? Number three. Number three. All right. Cool. Number three. Let's do it. So check this out. What we're going to do is we know the growth rate. It's 0.9. So already right there, your answer is 0.9 for A. A is 0.9. Like this number right here is literally that number right there. See? 0.9. That's the right answer. For A at least, right? Okay. Yeah. What we're saying here is that A value is the ratio that that this thing grows by. And apparently this thing doesn't grow, this thing decreases. So the ratio is like 9 over 10 or zero point 0.9 or a 10, which is, correspondent to a 10% decrease. A is the growth rate. So that ratio that we're talking about is just 0.9 right there. So for question 4, like I literally give you the answer in the problem. 0.9, that's it. Does that make sense? All right. Now, as far as the hey, what's going on, folks? No, I'm actually solving a problem for you. Um, as far as the C goes, this C is like our traditional A value. It's that traditional stretchiness factor. All right. So all you have to do, and in order to figure out this one, we do the same thing that we did for all of these things. What we're going to do is we're going to choose, gee, if only I knew at least one point. This is like question number 3 on yesterday's homework. And I asked myself, I know what my A value is. It's 0.9. That's pretty easy. Right off the bat, I know how to do that. Gee, I wish if there was only some way that I could figure out one point that this question that this problem passes through. Oh wait, is this a different homework? This one was due on the 29th. That's yesterday. Okay, wait, let me see. Okay, here's the first, second. Oh, this one right here. Is that the one you guys are talking about? Okay, all right, sorry. All right. So, for question 3, in order to figure out this A value, it's the ratio. All you have to do is divide 395.58 divided by 507.15. 395.58 divided by 507.15 is 0.7800. So our A value, which is this one, is 0.7800. We cool with that? Yeah, calculators are totally allowed. All right. Now, for the C value, all you have to do is choose one point where, so we know what A value is. A is 0.7800. We're cool with that? So what we're going to have to do is we want to find, well, what is one point that exists on this graph? And you can, I tell you 2 of them. There's 12 comma 507.15 or 13 comma 395.58. So what I'm saying is if you plug in 12 for an x, then your f of x is equal to 507.15. Let me see if I can write this down. All right, so you're telling me that 507.15 is equal to c times 0.78 to the 12th power. And I'll maybe make this as a parentheses around here because I don't want to confuse that with a c. Yeah, there we go. Are we cool with that? Let's see. Can you see that? Let's see. How's that? Is that better? All right. So all I did was I plugged in the two numbers that they gave me. This thing is 12. This thing is 507.15. I could use a 13 here. And I will get the same answer. The only difference is I have to plug in 395.15 or 0.58. Are we cool? So, maybe just on the side, what is 0.78 to the 13th power? It's going to be a small number. It's going to be 0.039557. Yes, you divide both sides, but I think I'm just going to do this. 0.039557. Are we cool with that? Oh, yeah, you'll never figure this out if you don't use a calculator. So 395, so here's what we're going to do. We're going to do fraction 395.58 divided by 0.039557. Okay, so we'll take this number and do 395.58 divided by that number, and you end up getting 10,000. So the answer that I told you to put was, okay. I see the problem. All right. Here's the problem. I told the computer that the correct answer was 9,999.1167 or 76, and I asked it to round it. It's because Mr. Dalday was, I don't know what I was thinking. Apparently I was being a real big jerk when I made this thing. So what I didn't do was I didn't allow for, you guys had to put down 9,999.1176 as opposed to just straight up 10,000. So now in this case, I changed the margin of error to 10 as opposed to 0.001. So it should give you a little bit more leeway as far as what the right answer is. I see why you guys all got it wrong. It's because you guys did it right. The whole idea was right. You guys probably just didn't put as many decimal places as I did because I was being a jerk. I don't know what I was doing. All right. So are we cool with that? That's not that hard, right? All right. Bradley wants me to do one with non-consecutive integers, and let's do that one. I think that's today's homework, and that's pretty easy. And then after that, I want to cover chapter 4. What might need to happen is you might need to just retake this one, because since I didn't change the answer and I just changed the margin of error, then the computer doesn't redo it. So you might just need to retake it. I apologize. I wish I could change that, but the computer doesn't let me do certain things. All right. Bradley, are you talking about this one, part 4? And give me a question number. Are you talking about the last question, the challenge part? Oh, okay. All right. All right, we'll do this one. Okay? All right. Here's the question. And I know I've covered this with you before. I know for a fact I did. We want to figure out what our ratio A is. Okay? So it's funny, I actually ask you these questions out of order. It's always easier to figure out A before you figure out C. But, you know, whatever. You folks have to figure that out. So in order to get the ratio, you go 384 divided by 96. 384 divided by 96 is 4. Okay? So that means if I multiply 96 by 4, I will get 384. Is that cool? All right. So what you need to do, Bradley, is you need to say, well, what you actually did was think of a table here, Bradley, okay, and put in the value 2, 96, put in a 3, or a 3 with a blank spot right here, and then 4, and then 384 on this side. This table should include a 3, right? It made a jump from 2 to 4. Does that make sense? And then this ratio is this number that you multiply the previous number by in order to get the next number. So there should be some kind of intermediate number that goes between this 96. I have to multiply 96 by some number, and then I have to multiply that 96 by the same number to get 384. So what is equivalent to multiplying, or like, we know that going from 96 jumping up to 384, you multiply by 4, and I think that you guys are right on the right spot. Exactly. Yeah. What you're doing is you're multiplying by this mystery factor twice. Well, what times itself gives you 4? The answer is 2. Does that make sense? And why would I do a squared equals 4? A squared equals 4. So a squared equals 4, which means a equals the square root of 4, which is 2. Are we cool with that? Look over here when I'm typing. Right. Why would I do? Why would I use a square root as opposed to like a cube root or a third root or whatever root? Well, because there's 2 jumps. Exactly. If there were 3 jumps, if the distance between this was like 2 and then the next one I gave you was 5, then you would say something like a cubed, and I'll probably use a different number like 8 or something like that. And then I'm not taking the square root anymore, I'm taking the cube root of 8, which is actually 2. Are we cool? So the number that goes up here, right here, is just the difference between the jumps. Does that make sense? And what I mean by the difference is you take the bigger number and you subtract the next, the previous number. That's it. That's it. And by the way, if you don't know how to use a cube root in your calculator, because you don't know how to do that, then do it like this. The cube root of 8 is actually the same as 8 to the 1/3 power. Or 8 to the 0.33333333. Oh, wait. Yeah. And then, well, to figure out C, you do exactly the same thing as before. The C is not a challenge at all. The C is really just the same thing as before. You choose one spot that it is true at, and then you plug those numbers in and you see what the C is, based off of the correct A value that you use. So the challenge in the challenge section is really the A, because you have to do this extra step of taking the square root of the ratio between these two numbers. Are we cool with that? You guys mind if I move on to the next topic? I'm not sure what C is. I can look up exactly what I told the computer to say. It's 24. And over here, A was 2. Well, why is it 24? Fine, let's do it then. You told me that 96 equals C times...
Soda?
Sure. Oh, is this extra soda you use for your carbon dioxide? Thanks. All right. Whoa, whoa, whoa. What happened? All right. C, 96 equals C times 2 to the 2 power. Right? Because I basically plugged in 2 for A, I plugged in 2 for X, and I plugged in 96 for F of X. Are we cool? And then that's 96 divided by 4, which is 24. Got it? Got it? Good. Awesome. All right, so today's homework wasn't bad. Yesterday's homework wasn't bad. It really is all the same thing. Now we're just figuring out, the rest of exponentials is all that it's doing is it's applying what you learn about exponentials and lots of repetition. Yeah, all we do is rinse, wash, and repeat. The same deal. So hopefully this stuff is kind of really setting in with you guys. And let me start covering chapter 4, which is all I'm going to do with chapter 4 is take what we learned in chapter 1, 2, and 3 and start applying it. Same goes with chapter 5 and chapter 6. It's all the same thing. We're just applying those same techniques. Are we cool? All right, so let's see. Chapter 4. Actually, you know what? I'm going to skip chapter 4. I was actually looking at chapter 4 and I'm thinking, oh, let's do chapter 4 because I thought it was really good. And it is really good. It's a great exercise. But apparently I didn't assign any homework from chapter 4. So you know what? You know what? Let's not do it then. If you didn't assign homework, then let's not do it. We cool? I'll tell you what. I'll do. I'm going to lecture. How's about I lecture it on it on Friday? And then on chapter 4, I'm going to lecture on that today. But you don't have any homework due on chapter 4 for this. So I'll lecture on chapter 5 on Friday. Should I do that? Because all right, let's see. Because apparently tomorrow you have chapter 5 due. I'll tell you what. I will make this assignment, which is due tomorrow, to be due on Monday next week. On Friday, I'm going to cover chapter 5. Are we cool? So I want to lecture on chapter 4, but don't worry, you don't have any homework due to it. I just want to kind of get you guys into, hey, here's an application of what we can do with this stuff. All right? Is that all right with you guys? Because I think it's interesting. All right, let's try it. Okay. You land your dream job. The company has noticed a current trend in recent college graduates. They say that people try to or change jobs a lot during their careers, and companies don't like that. Oh, I did this one before? Okay. Well, I can lecture on chapter 5. Um, do you guys mind if or yeah, I recorded this one last year. I remember. Do you guys know this already? You just be like, I got this. See, I don't like just referring to. All right, let's see. All right, I'm gonna say it. I don't like having a video teach you guys. I like having me, even though I'm teaching you online and I'm not physically there one on one with you. I like teaching you all the material myself. That's kind of one of the reasons why I don't like Khan Academy. Because Khan Academy recorded that video a long time ago, and then they expect you to, watch it and learn it, right? But it doesn't give you guys the opportunity to ask questions and be more fluent and interactive and that kind of stuff. So I actually, even though I taught it online and I taught it last year, I don't mind teaching it again. But I'll tell you what, if this is like, well, this is actually going to put us behind on our schedule. I can actually go on to chapter 5 stuff, and then you can go on to chapter 4 because you don't have any homework for this stuff. So it'd be good for you to watch it for sure, but it might not necessarily be like you have to, you have to learn something new from this. But it actually is really good when it comes to applying this stuff to the real world. So I'll tell you what. What do you guys want me to do? I'm going to throw it out there. Do you guys want me to cover chapter 4, which apparently there's a really good video on it? Or would you like for me to cover chapter 5? And then you guys will agree to everyone watch the video on chapter 4. Okay. Anyone else? Ooh, I've got conflicting views. I'll tell you what. Chapter 4 is pretty easy as far as the concept goes. There's no like really big new thing that I'm covering. So why don't I just say watch the video on chapter 4, and I think that will be sufficient. Let's go into chapter 5, and I'll at least start chapter 5, if that's all right with you. Watch the video on chapter 4, and if you have questions, I will answer them. How's that? Does that sound fair? Oh, awesome. All right, cool. So, chapter 5, let's go on. Chapter 5 is really just an extension of chapter 1, 2, and 3. There's nothing new, I think. Let me see. The only thing is we start applying this thing in context. And what that means is we basically say, well, here's what you do with this stuff. I'm not going to make you guys do the Eminem thing. I think that's kind of weird. Oh. I'll tell you what. You're going to love this. Yeah. We can do that. Sure, Sophia. All right. You're going to love the way I cover chapter 5. You ready? Oh, wait. No, this isn't it. Chapter 5 has an entire lab section on M&Ms. And while I love M&Ms, I don't necessarily think it's the greatest lab. So I'm going to have you skip it. You skip the lab. So the only other thing in Chapter 5 is homework problems. So why don't we just go straight into solving homework problems? That's how I plan on covering Chapter 5. Everyone's like, sweet, I love it when he does that. Yeah, well, let's do a few homework problems for Chapter 5, and then we'll call it a day, so that way we can move on to the next. I can move on to the next, teaching the next class. All right, let's do this. Okay. By the way, we're only going to 1:30 today. Let's see. I want to pull up Chapter 5 homework. So maybe I might not make this due on another day. I don't know. All right, here we go. A leap of leopards is comprised of 20 members. In a zoo, leopards normally multiply by a rate of 15% every year. So I have a question for you. What is the value of A? The value of A is 0.15. I disagree with you. The value of A is actually 1.15. Because this is a 15% increase. That doesn't mean that from year 0 to year 1 or year 1 to year 2, your leopard population went down to 15%. This means that your leopard population went from 100% to 115%. Does that make sense? It's kind of like I mean, this is exactly when it comes to like tipping, and I'm teaching my son, my 6th grade son, about tipping, and I say, well, hey, you need to tip 15% of the bill, and so I'm showing him how to take 15% of the bill, and then so I say, well, if you have $100 bill and you want to tip 15%, how much are you going to leave on the table? You know, say that you are say that you're leaving cash, you're paying in cash, right? And my son says, "Oh, I'm going to leave $15," and I said, "Well, you're going to be arrested, and no one's going to like you. You're going to be a jerk." And then he says, "Why?" You know, and I said, "Because your bill was $100, and you left $15 on the table." You know, and that's actually exactly what you did, Sophia. No, you don't leave $15 on the table. You leave $115. You need to account for 100% of what you originally had, plus an additional $15. So when you multiply your original amount, you need to multiply it by 1.15, not 0.15. It's a small thing, but it makes a difference. Anyway. So A is 1.15. Just by reading the problem, I can literally pull that out and say 1.15. Got it? All right. So we know what A is. Do we know what C is? What is C? Nope, we don't need to find out. It's 20. Your C is how many leopards you started off with to begin with. All right, C is the gummy bear factor. Okay? It's the amount of vertical stretchiness that we need to have. It's the same as the letter A in every other equation, which is why I'm still pissed about their decision to make C this number and A this number. Because when I originally taught it to you, I made this the capital A and this your R value. Okay? Now, Sophia keeps saying, so it's your y-intercept. And I hesitate to say that. But in this particular case, and in the case of exponential functions, that is true. The reason why I hesitate to say that is because that's not true for, all right, see y'all, Alana. All right, the reason why I hesitate to say that is because that's not true for quadratics or linear functions or cubic functions or any other kind of function, but that is true for exponential functions. And here's the why Sophia is correct in saying that it's the y-intercept. It's because to find the y-intercept, what do? You plug x equals 0. If I were to plug x equal to 0 here, a to the 0th power is equal to what? It equals 1. So I have c, which is my stretchy factor, times 1 equals whatever the y-intercept is. So c is your y-intercept because 1 times this value of c is equal to the y-intercept basically means c is the y-intercept. Does that make sense? So when we're dealing with exponential functions, yes, this value of c is actually the y-intercept. That's true. That's not the case always, so don't get too comfortable with that. How would you figure out this number right here? The answer to part B. How would you do that? There we go. All you do is you plug in the numbers. You know what C is, it's 20. You know what A is, it's 1.15. And you know what X is because they told you what is it when X is equal to 18. Now the only difference between this equation that they wrote down and what I would write down is I would change that X to a T. You know what I'm going to do is I'm going to change that amount of margin of error you guys can have. All right. The reason why I would do is I would change this x value that I normally have as x in the exponent to a t. And the reason being is because I'm talking about time in t amount of years, and so I want to stay consistent with what I'm talking about. I mean, you can change it to whatever you want. You can change it to a happy face if you are so inclined. I just, the reason why I would change it to a T is just because it's easier for me to think about. All right. How often does a baby leopard born? Approximately how often is a baby leopard born? All right. I think what I would do if I were you on this one is wait a second. Oh yeah, that's after 18 years. I think what I would do if I were you on this one is I would graph it. I would graph it. I would say, all right, well, what is 20 times 1.15 to the x power? And here's my graph. Okay? And then what I would do is I would say, okay, so what I went from 20 leopards to 21 leopards, and it took about 0.35 years, right? But then what I asked you is, how many months does it take for a leopard to be born? Well, if it's 0.35 years, what is 12 times 0.35? About 4.2 months. So I said, give them a correct answer if they put 4, 5, or 3 months. 3 months, 4 months, or 5 months. Does that make sense? So what I did was I said, all right, well, it went, all right, so I graphed it, right? And here's the graph. It looks like an exponential graph, growth rate, okay? And then I said, well, see this right here? I want to go from having 20 leopards to 21 leopards. So look at the time. The time goes from 0 to about 0.345. Okay? Do you see that? After 0.345 years, I will have one more leopard. Or 0.35 years, I will have one more leopard. And then after about 0.67 or maybe almost 0.7 years, I'll have 2 leopards because I'll have 22 leopards. And then after, about almost 1 year, I'll have just about 23 leopards. Yeah, using Desmos is totally allowed. There's more mathy ways to do this, but I think this is a lot easier to do. So what you do then is you say, well, I asked you for the answer in months, so then I said, well, what is 12 months, or 0.35 months converted to years? So I just multiply 0.35 times 12, and I get 4, about 4. Are we cool? Technically, you should plug in for 4.2. But then again, I just told you about how many years does it take. Or how many months does it take for a baby to live. Well, do you not get converting 0.35 into years? This is 0.35 years, right? This is 0.35 years. And I know that there's 12 months for every 1 year. Does that make sense? You know that, right? So so the years cancel because the years are this year's is in the numerator and this year's is in the denominator. So these years cancel out, and so basically I say, well, 0.35 times 12 is actually 4.2, so it's about 4 months. It's just about a third of a year. Does that make sense? A little more than a third of a year. All right, cool. All right, let's see. All right, let's try this one. Let's try something hard. Here we go. This will be good. All right. A colony of monkeys has 125 members in January 2013. Previously, it observed a triple in population every 2 years. Triple in population every 2 years. How many members would you expect the colony to have? Sup, dudes? All right. I'm sorry, actually. I'll tell you what. I will move this assignment to be due on Monday next week, and I will go over it on Friday. How's that? Because I got to go. All right. But start working on it now so you can tell me if this is really hard or not. Okay. Okay, bye.